energy of falling water into a useful mechanical energy, and then converting the mechanical energy, in this case, into electrical energy. This is just a model of one, but it's a working model, and it's pretty well the same as any large hydro schemes have the same elements. The physics of it is you've got a reservoir or a river higher up and a fall of water down to a lower point. And what you do is you put a machine at the bottom, so you develop a pressure difference between the top and the bottom. And the pressure of the water, you need a volume of water, and the volume of water and the relationship between the volume of water and the head, the height of water, and the watts out can be calculated. We'll do that in a minute. The elements are the same. What you've got here is a reservoir at the top, pipeline, and a volume of water, and control it. The water forms a jet, hits a wheel, it's got buckets on it. As I speed it, turn it on, show you there's no tricks. Now at the moment, there's no load on this at all. So the wheel is running at the same speed as the jet, and there's no power transfer. This is no load. If I switch on the light bulb, electricity, there's no tricks, that wasn't on before. But you notice what happened is it slowed down. Put that on. You look here, you see that what's happening is the jet is hitting the bucket, and now the jet is being reflected back on itself. And from that you'll change in inertia, you're extracting the energy from the water. If I increase the load, it slows down even more. If I increase the load even more, the wheel slows down, so the jet is coming right back on itself. Okay, so what we're going to do, set it onto the light bulb. Turn it off because I'm losing the voice a bit. Okay, come over onto the board over here. I'll just take this last lot of results off, because you're going to get some more results in a minute. Leave that up. That one needs to come off. Okay, now the relationship between the power output for any hydro scheme, however big, whatever type of turbine, and it's in your workbooks, but it's not quite in the same units, and this is because it's easier for us practically to use these units. The relationship for your input power, how much power are we going to actually put into the machine, is the pressure difference. That is the pressure at the jet, that is the pressure that's generated by the height of water, times the flow rate, how much water are we using, times acceleration due to gravity. Now the units we're using here, because it's easier to work it out, are a head in meters. You might have it in kilopascals, but there is a relationship. You could have it in bar, which is meter is reading. Big difference is the flow rate here. You will have a mass flow rate. This is the volume flow rate. It's very hard to measure mass flow rate because 1 litre of water weighs 1 kilogram. So you could say that the flow rate actually is proxy for mass flow rate. And if that is in litres per second, our input power will be in watts, which is what we want. So what we're going to be measuring is the head in meters, the flow rate, and we know what acceleration due to gravity is 9.81. Now we need to know the output power. And the output power is we measure the output power by measuring the volts and the amps, multiplying the two together. Output power, electrical power is watts, and you will get that by multiplying your amps by your volts. Now we also like to know, we saw that as we put the load on, put the lights on, the speed decreased. So we need to know the relationship between the speed of the machine and the watts power out. That's what we're after. So what I need you to do, I was looking for that, thank you. How many have we got? 2, 4,
8.
6, 8, right. I'd like 2 people to scribe and calculate. Okay. 2 people to measure the flow going into the machine. I'll show you how to do that in a minute. 2 of you to measure the voltage and the amps, and 2 of you to measure the speed. So break yourself up into pairs. Okay, do you 2 want to do the speed measurement? I'll show you that in a minute. So this is the volt? No, that is the pressure in the pipe. Yeah, now that was
بنحطها على قياسات معينة.
constant, and the pressure will be constant. So when the machine is settled down, read that off on the red scale. Gives the pressure in bar describes. People are writing down.
So now, how much is it? 2.8?
No, it's nearer. Yeah, it's just over 2.8. But wait until it's running, because we're going to get pressure losses when it's running. Now I want you to measure the way you measure the flow, how much water there is coming out. Got a bucket, and you'll see graduations down here. That's the 10 litre mark. So what I want you to do is to fill the bucket up to the 10 litre mark and time how long it takes in seconds. You do it 3 times and then average it. Okay. I'll wait, when I've turned it on, wait for a couple of minutes to let it stabilise, because you've got to accelerate a column of water, and that takes a little bit of time.
Measure it to which number?
10 litres.
10 litre, yeah?
Yeah, that's that mark there.
Okay.
And then tip it away and do it again, 3 times. And take an average of the time that it takes. I'll come round that way in a minute. I'm going to send to the lowering machine. That is voltage, and that's the code. So when we start, you give these readings to our scribes here. Okay, now we measure the speed with a handheld tachometer, and when it's running, I'll come round and show you how to do this. I'll show you how to do it. I'll demonstrate that. And you read this out on the outer scale, because I know that the range of the speed is somewhere between 0 and 2000 RPM. Okay, so I'll turn the machine on. Important to open the valve right up, open it completely. Right, there we go. Right, here we are. Right, I'll come around this side and to measure the speed. Who's the speed measure here? Who else?
Speed and
Your speed, right, okay. Just rest that gently on your finger, and then you've got to push it in positively. And you read that off 12, 13, 14, no, 12, just over 13. These are 500. Yeah. Those are 500 RPM. That's 50 RPM. So that's 13. About 1320. Have a go at that because it's a little bit tricky. Now you need your other hand. No, don't hold it. Just rest it on one hand like that. No, you hold it.